if something is a factor, if I ask you if something is a factor, you literally just plug it in and see if the remainder is 0, right? If the remainder is 0, it's an x-intercept, therefore it's a factor. Because remember, we plug in to see if we have an x-intercept. So even though this is x minus 2, we would actually be plugging in 2. And if what comes out in the remainder is a 0, that means y is 0. We have 2, 0 as a coordinate. We have an x-intercept. Then x minus 2 was a factor, right? That's what we learned yesterday. The reason why we have to learn if something is a factor is because if something isn't a factor, we can't do synthetic division with it, and we can't factor the whole polynomial up. That's literally the reason why we learn about factors here. Okay? So we're going to plug that in. We're going to say p of x equals x cubed minus 6x squared plus 3x plus 10. And we're going to see p of 2. 2 cubed. Oh my gosh. Minus 6 times 2 squared plus 3 times 2 plus 10. We get 8 minus 24 plus 6 plus 10, which is positive 24 minus 24, which is 0. So we have p of 2 equals 0. So we know we have an x-intercept, 2, 0. True statement? Which means that x minus 2 is a factor because the remainder is 0. So if I went to my calculator and typed in that, x cubed minus 6x squared plus 3x plus 10. I actually have 3 factors. Because how many x-intercepts do I have? I have 3. And the x-intercepts work backwards to a factor. We agree? So I have an x-intercept at negative 1. What's my factor? X plus 1. And if I go here to my table, okay, I go here and I look at this negative 1, 0 spot. That's an x-intercept, correct? So x equals 1 is the x-intercept, so I move it back over, so it's x plus 1. Where's my other x-intercepts? Oh, here, 2, 0. So I move it, x equals 2 is my x-intercept. So x minus 2 would be my factor. Here, x equals 5, x minus 5 would be my factor. That's all you do, right? Okay. Next page, I think. Oh, no, not next page. Is this the next page? Next page. I don't know how I just got there. I must have hit the arrow by accident. So, this is an aggressively large page. It looks like it takes an aggressive amount of page. It doesn't. It's deceptive. It takes a bit of page, but not a whole page. But we're going to go through it anyways. So we have x cubed plus 2x squared minus 5x minus 6. Okay? The first thing we're always going to do is we're going to state the possible zeros. Zeros is another word for x-intercepts, correct? Roots. Roots is another word for x-intercepts. Why do we have so many words for x-intercepts? I don't know, but we do, so we use them. So we adapt. So roots, zeros, and x-intercepts all mean the same thing. So I'm going to write that just to remind myself. These are interchangeable. So we have to identify the possible zeros. And the reason why is if I took the calculator out of your hand and I said, no more, you would literally have to plug in the possible zeros and try and find one that got you a remainder of zeros so that you had an x-intercept. Right? That's how you'd have to do it. you wouldn't be able to go to your table of values and look for an x-intercept like we just did. We found 3 of them, correct? With my table of values on my calculator. If I take a calculator away, though, that'd be gone. Also, on tests, it can say, determine which of the following is a possible factor. And then people will say, well, I plugged them all in and none of them got 0. I didn't say which of the following is a factor. I said which of the following is a possible factor. Yeah?
No, I don't know this because I don't know what the difference is.
A possible factor means it's numbers I could plug in that could possibly get me a factor. And I haven't taught you that yet.
Oh, okay.
So you're in learning zone. Okay, so where do I find those numbers from? Well, the possible zeros come from the factors of your constant. The constant is the number that remains the same. The constant is the number without a variable. That is what a constant is. Because if I plugged in something for x here, here, and here, these would all change. But the -6 would stay the same, right? It's a constant. No matter what x I fill in, that baby's staying -6 because there's no x beside it. So your possible zeros are based off of this number, the factors of it. So I always state those first. So my possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So if on a test I had A, B, C, D, multiple choice, and I said, what are the possible zeros? And one of them was x minus 7, or possible factors, sorry. And one was x plus 8. And one was x minus 6. And one was x minus 4. Which would it be? C. It's a possible zero. Plug them all in, probably don't work. Yeah?
Hey, why did you say it skips from 3 to 6?
It's just factors of 6. So it's what multiplies to give you 6. So 1 and 6, 2 and 3. Yeah. So it's only the numbers that you can multiply to get you that number. So the possible one would be C. Yeah. Yes. So we have to learn how to factor. So if I didn't have my calculator in front of me, I'd have to plug in -1. Check. Do I get a remainder 0? Nope. +1. Plug it in. Do I get a remainder 0? Nope. +2, -2, +3, -3, till I got a remainder of 0. That's how I have to do it without my calculator. However, I have a calculator. So I'm going to plug it in. Everyone should be doing this. Remember, just because I'm using my calculator does not mean you shouldn't. That's what deters me from wanting to use it after here, because you don't go plug it into your own. And then people don't realize they don't even know how to get a cubed on their calculator. So I have x cubed, arrow over, plus 2x squared minus 5x minus 6. Looks like that. Now, you can pick any of them to do synthetic division. If you would like to follow along with me when I release you and say, you try it on your own, and then we go through it, I will always pick the smallest x-intercept to start with. Then everyone, in the end, if you pick a different one, it's fine. You'll end up with the same factors, all 3 factors. You'll end up with the same ones. You won't be doing synthetic division with me, though. You'll be doing a different one. So I always pick the smallest. You don't have to. But if you want to be able to see if your work is right compared to mine, pick the smallest. So I go to my table of values. It looks like it's at -3. But I have to check and see that 0 is actually 0 there. Because it could be like -2.999, right? We don't know. So I'm going to go second table. And it is. It's -3. Now some people will say, well, I know it's -3, -1, and 2. I'm done. Cool. It says algebraically. You've gotten no number, no points. None. No points. You just pulled it off your calculator, right? So they'll say algebraically. So I'm going to pick -3. So I'm going to go P of -3 and see if I get 0. Because just because you cheated and got it off your calculator doesn't mean you can't show them. You have to show them that it worked. You just miraculously guessed the right one, is what they think. Miraculously guessed it because you only showed one and it miraculously worked, right? But you have to show that it does work. So you get -3 cubed plus 2 times -3 squared minus 5 times -3 minus 6. And we get -27, bless you. And then +9 squared times 2 is 18. -5 times -3 is +15. minus 6. This is negative 33, it's positive 33, 0. Now it says factor. So in the end, we have to have factors. Factors are those things in brackets, right? Like when we factored x squared minus 3x minus 4, we got x minus 4, x plus 1. Those are factors, right? Factors are in brackets. So ultimately, I need factors. I need brackets. Okay? How are we going to do this? This is where we're paying attention. We first, number 1, oh, board, I hate you so much. Number 1, rocket count. You learn about this in kindergarten, so I believe in you. Okay? Rocket counting is like 5, 4, 3, 2, 1, blast off. If you can do that, you can rocket count. So, in order to do synthetic division, we have to make sure that we can rocket count the exponents. If we can't rocket count the exponents, we have to put in a placeholder. So, let's go up here. What the heck is that? Okay, I have 3, 2, 1. This would be x to the 0, right? Because x to the 0 is just a 1. 3, 2, 1, 0, blast off. Yay! I can rocket count. If I can rocket count, I'm good. For example, what does not being able to rocket count look like? Well, if I had given you like, I love this board so much, it's so great, it's big, so awesome, I love it, awesome. What if I did that? 3, 1, 0. That might be a kindergarten kid counting. Blast off! That could be a true case, but we need to be a real rocket counter. Can we rocket count this? What are we missing? I hope you all know. What number are we missing? 2. So I would have to actually rewrite this as 2x cubed plus 0x squared minus 2x plus 6. Can I now rocket count? 3, 2, 1, 0. Blast off. Yes. Then I'm good. You always have to check for rocket counting. 99.9% of synthetic divisions going wrong are you not rocket counting, you miss the 0, you plug it in, and you don't get a remainder of 0, and you're angry. You call me over, and you're like, Lepp, I put in my, you like give me all your steps. You're like, here's the calculator. I put it into y equals. I went to my table. It told me -1 worked. -1, 0. Perfectly fine. I go here. I put the -1 in. I do synthetic division. I go down here. I multiply, add, and multiply, add, and multiply, add. And I don't get a 0, and you're just angry. Like, you went through all the steps, and I'm like, cool. You're missing step 1. And you're like, no, I put it in my calculator. And you go back through it, and I'm like, and on the test, I can't tell you. If you're not getting a 0, 99.9999% of the time, you didn't rocket count. You're missing that 0 placeholder, and it will never turn to a 0. Okay? Step 1, for synthetic division. Can I rocket count? Yes. Poof. I did. Yay! I also remember this day in high school, grade 11, because we did 30 A, B, C, and calculus in Saskatchewan. I had so much math. We did 30A in grade 11. So I remember doing this. And I remember specifically the teacher telling me, leave enough space for 2 rows. And then I didn't. And then I had to erase it. And I remember being annoyed. So, leave enough space for 2 rows. What does that mean? When I make an L like this would be 1 row. That's stupid. Don't do that. Okay? That would hold 1 row of numbers. I need 2 rows of numbers. So I make a long L. Like it goes long, like row 1, row 2. Okay? Deep L. If you don't, you'll be erasing it or squishing it, and you'll be mad like I was. And you remember this to this day, when you're turning 40 this year, and you still remember grade 11, not putting your L correct. Okay? Okay. Yes. So, at the front, I'm going to put x equals -3. Now I'm going to put x equals -3 because that is what x equals. Crazy, hey? What would the factor be? It's not rocket science. See, rocket counting, not rocket science. What would the factor be? X plus 3. Genius level, children. That's what you are. Okay? Now, along the top, this will seem overwhelming at first. You'll be like, what did she just do? What is this? And then within like 3 of them, you're like, multiply, add, multiply, add, multiply, add. It's the easiest thing. So if you can bypass the freak-out level, you will do well. All right. So we are going to put the coefficients, because we can count down. We're putting the coefficients. So not the variables, just the coefficients. I'm going to go 1. It's going to be crazy. 2. -5. negative 6. That should not be the overwhelming part. Okay? Everyone followed along? We're good? We got it? All over it? All right. Now, we are going to be like repeating machines until we're done. We're just going to keep doing the same thing over and over and over and over until we get our remainder. What is that? Well, our first step is drop down the first number. I pressed red. Drop down the first number, 1. You're all with me. Now, we are going to multiply and add, and then 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 multiply until we're done. That's what we're going to do. It's going to look overwhelming, but literally all we are doing is multiply, add, multiply, add, multiply, add. Okay? Cool. Multiply. I'm going to put arrows. It's going to look confusing. I'm doing it for one example, then after this I'm not writing the arrows anymore. I will write the first arrow, but none of these. Okay. Math brains. What's negative 3 times 1? Genius level, see? And it comes up here. We finished multiplying, so what now are we going to do, children? We are going to add. 2 plus negative 3 is what? Negative 1. We completed addition. So now what are we going to do? We're just multiply, add, multiply, add, multiply, add, multiply, add. So we finished adding, so now we're going to... Don't all answer at once. It's out of control. You're already all doing it. Multiply. You could just answer. Negative 3 times negative 1 is 3. Then we are going to, we finished multiplying, so now we are going to add. Negative 5 plus 3 is negative 2. We finished adding, so now we are going to multiply. Through negative 3 times negative 2 is 6. And then we're going to throw a party because negative 6 plus 6 is, here's my remainder, box it. So do I have to do a remainder theorem to find my remainder? No, I can do synthetic division.
Are you ever going to make us do that?
Synthetic division? Welcome to life. This is polynomial 101. Yes, you're going to do this like 777 times. I hope you enjoy it. It's fun. You're invited to the ride. Get on board. Okay. So, are you going to ever make it? This is like half of the unit. You're welcome. Okay. It's how you factor anything that's not squared. Anything that's higher, you have to do synthetic division. Silly rider. Okay. Get on board. Ride. He's a rider. See? Get it? Got it? Check. So funny. None of you laughing. All right. X plus 3. I took a factor out. Whew. Right? It was a what? What was the graph? It was an X cubed. I took one out. So now what's going to be? An X squared. True statement. So we took the X's out of this one, did we not? We have to put them back in. I took an X out. Don't give me that look. I haven't even taught you. You guys are giving me this look like I have no freaking clue what you're saying, yet I've taught nothing. So of course you have no idea what I'm saying. I just literally said the word X squared. You're like, every one of you, like she's failing me right now. That's the look you're giving me. Like she sucks. I have no idea what I'm taught. You taught nothing. I said the word X squared. Oh, my Lanta. All right, you should see your faces. It looks like you're like every single, it's like, smile, I get it, to like completely, utterly lost when I haven't taught anything, to smile once I've done explaining it, to completely, utterly disappointed in me, to smile. This is how it's like, it's, wish I should video you for yourselves. All right, so we had X cubes up here. We took an X out. This is going to be an X squared. Cool. So we're going to go 1 X squared, and then we work down like rocket counting. Minus 1 X minus 2. Cool fun fact. If I took this and I multiplied it by the factor I took out, I would get the polynomial I had. Whew. Mind blown. Right? Right? Now we're back to grade 11. Actually, we're back to grade 10. I know how to fix this. How do I fix this? You just factor it. Mind-blowing, I know. So we're going to write the x plus 3 again, because that's one of the factors. Then I need to factor this. What multiplies to give me negative 2 and I'm going to do it off this side, because I'm a rebel. X squared minus x minus 2. So what multiplies to give me negative 2, which is the outside numbers, and what adds to give me the middle? Well, we get negative 2, positive 1. And because there's a 1 in front, I can go right to brackets. X minus 2, x plus 1. We factored it. Want to know if you're right? Type that into y2. Make the line thicker. They should be the same. If they are not, you screwed up. That's all it is. Go to my y2, because I leave that in my y1 because I'm comparing graphs. This is just a factored form. That's just the standard form. Factored form, standard. Factored form, standard. X plus 3. X minus 2. X plus 1. And then I told you, if you have these calculators, so I have a colored one so that'll make it red. But if I didn't have red, I'd hit enter here on that slanted line and it would make it thicker. Now, why would I want to do that? Because sometimes you have a graph drawing like this and then your other graph is drawing yonder, like off the screen, but you're like, oh, they're on top of each other because you only see one graph. But really, the yonder graph never drew on top of the other graph. It's over here. So if you make the second one thicker, you'll see a thin one, and then you'll see a thick one drawn over top, and you feel confident in yourself. I'm going to see blue than red. Hey, I'm genius. I got this. Yay me. Go me. All right. So, look over here. This is for you. This is for you. What is this one? What's the problem?
It's not rocket counting.
No, rocket counting. Put a placeholder. You. You. It's like, I feel like Oprah. You get an A, and you get a B. You get a C and a D. And then you're like, but Lepp, there's not an answer key. How will I know if I am right? Calculator. Put in your original. Put in your factored form. And they should draw on top of each other. Sorry, I can give myself a clap. Thank you, thank you, thank you. I'll be here all day. I'm not leaving. Okay.